I love my new lathe and I love the digital readout on it. They're fantastic. Only trouble is the scale for the digital readout is here on this side of the cross slide. And the lock for the cross slide is way up in there. And honestly, it's completely impractical to try and use it. So, I have a plan. Over on the front of the cross slide is the mounting point for the follow rest. And it's not unusual to see people use this as a mounting place for some kind of lock. And the most common design is a block that goes here with a threaded knob that screws in and pushes against the cross slide. And that will work. Problem is, I don't want to be reaching over here when the saddle is all the way up close to a rotating chuck. And it's not always convenient to shut the machine down. I want to be able to lock it from over here. I have a plan. Quick look at the basic design then. Steel block, brass cam, actuator shaft and knobbage. So the block gets mounted to the saddle in the position where the follow rest usually goes. It's mounted using a pair of custom bolts which have the equivalent thread in so that the follow rest can be mounted to this assembly so that this assembly does not have to ever be removed. This relief is cut into the block and that allows this face to come very close to the cross slide. And then the cam is just proud of the surface just enough to impinge on the side of the cross slide and lock it in place. There will be a through hole, actually counterbored in the brass cam here with a tapped hole in the shaft so that a screw can be put in there and lock this in place. And then we have a little lever at the end and this will come out right up next to the cross slide hand wheel so that you can actuate this and lock the cross slide wherever you have the carriage, whether you're close to the chuck or whatever. So nice, safe and simple device. This being about 2.5 inches long should give plenty of friction to hold the cross slide in place. So that's the idea. We'll make a start with this mounting block today. Let's go take a look. In keeping with the traditional approach, here's a rusty old piece of steel that I just cut from the parent block, and it's not at all square, so we're going to take care of that right now. I had this cheap fly cutter in my toolbox. It didn't fit a 3/8 inch tool. I also happen to have that from a long time ago, and this fallen into lack of use. I did have to just mill the slot out for this touch to get this in, but I'm going to try this. Following on from poor surface finishes on the adjusting block. See if we can do better with this. This block isn't square, so I'm using this round bar so as to not influence the position of the part while I get it squared up. Here you can see I'm doing the same thing by putting the round bar underneath it so that only the moving and the fixed jaw define how the part is held. The round bar is in evidence again. So again, that was just placed underneath the part to support it, but so that the two jaws define how the part sits. And this allows us to get the part square as I clean it up. Nothing very complicated here, just making passes backwards and forwards, taking off about 20 or 30 thou at a time, keeping it real easy, just relieving this area where the bracket gets clamped to the carriage. To remove the material in the pocket where the locking cam is going to sit, I'm just drilling 4 holes first, so using a centre drill to make pilot marks first, then coming in with a larger diameter drill to open up some starting points, and then I'm just going to use an end mill and plunge cut most of the material out to leave a rough pocket. Then I'll come in with an end mill, walk around the edges and the bottom face and clean it up. This is the start of the plunge cutting process, and this is just a matter of stepping over until the pocket is mostly cleaned out. Pocket's mostly cleaned out. You can see it's pretty rough, but I haven't finished it yet, and that's what's next. I completely wrecked perfectly good end mill. This is a carbide end mill. Don't know if you can see that. So the plunge cutting works and you can remove a lot of material quickly with it, but you've got to be a little careful with it. I think I was taking far too large cuts. I might have been better off doing that hogging out with just a high-speed steel mill, to be honest, and then use this one to finish it. So there you are, be warned. It's a good technique, but it's hard on the end mills, which, as it happens, an actual machinist told me recently, so I was forewarned. Oops.